Now we'll look at two examples of estimating the value of a partial derivative using a contour map. A contour map of f of x comma y is shown. We want to use it to estimate the partial derivative of f with respect to y when x is 3 and y is 20. This represents the slope of the tangent line in the y direction at this point. We can estimate the value of a partial derivative, which represents the slope of a tangent line, by using the slope of a secant line. To estimate the partial derivative of f with respect to x, we would use the slope of a secant line in the x direction, where we would find the change in the function value and divide by the change of x. And to estimate the partial derivative of f with respect to y, we'd use the slope of a secant line in the y direction, so we determine the change in the function value and divide by the change of y. So going back to our first example, let's first locate the point 3, 30, which would be here. Notice how the function value is 360. Let's go ahead and record that. F of 3, 30 equals 360. And now to find the slope of the secant line to approximate this partial derivative, we want to find another point in the y direction. So let's sketch a vertical line parallel to the y-axis here. So the second point must be somewhere on this vertical line. And of course, the closer it is, the better. Let's go ahead and use this point here because we can easily determine the function value at this point. Notice how the x-coordinate is 3 and the y-coordinate looks like it'd be about 21. So f of 3, 21 would be equal to 270. And now we can use this information to find the slope of the secant line to make our approximation for this partial derivative. Partial of f with respect to y will be approximately equal to the change in f divided by the change of y of this secant line. So the change of f would be 360 minus 270, and the change of y would be 30 minus 21, which equals 90 divided by 9, which equals 10. So our approximation for the partial of f with respect to y would be approximately 10. Let's take a look at a second example. We have the same contour map, but now we want to estimate the partial derivative of f with respect to x at the point 2, 5. So here's the point 2, 5. Notice how the function value is 90. So we know f of 2, 5 equals 90. And now because we're finding the partial with respect to x, let's sketch a horizontal line that's parallel to the x-axis and select a second point on this horizontal line. Let's go and select this point here. Notice how the x-coordinate is 4, the y-coordinate is 5, and the function value looks like it'd be somewhere in between 90 and 180. Let's estimate the function value to be 135. So we'll say f of 4, 5 is equal to 135. And we use the slope of the secant line in the x direction to approximate this partial derivative. So the partial of f with respect to x would be approximately equal to the change in the function value divided by the change of x using these 2 points. So the change in the function value would be 135 minus 90, and the change in the x value would be 4 minus 2. So we have, 45 divided by 2, which is equal to 22.5, which we'll use for our approximation for the partial derivative of f with respect to x. I hope you found this helpful.